Hi, everyone. Thank you for attending our webinar today. Good afternoon or good evening or good morning, depending on where in the world you are. My name is Vikram, and I'm joined on the call by Rob Bishevsky, our Director of Engineering. We are from GL Communications, and today we want to talk to you about a very popular solution of ours called the MAPS Analog Phone Simulator. For those of you who may not be familiar with us, we are GL Communications. We are headquartered in Gaithersburg, Maryland, United States. We also have offices in Bangalore, India, and Shanghai, China. We were founded in 1986, so we've been in business for more than 30 years. And we do a wide range of different stuff in the telecommunications industry. We do telecommunications consulting services, and we also manufacture test and measurement equipment. And we actually make this equipment for all telecom networks, regardless of whatever network you're trying to explore or test or emulate. We have equipment for the public switch telephone network. We have equipment for Ethernet IP, for wireless networks, SONET, SDH, land mobile radio, all sorts of different networks. We can supply test and monitoring and measuring equipment for those networks. And in terms of what we can do, we can analyze these networks, we can monitor them, we can visualize the traffic, we can capture traffic, we can store traffic long term. We can also emulate certain traffic and simulate different types of network conditions. So we can do a lot when it comes to interfacing with these telecommunications networks. Our customers include a lot of big telecom service providers, as well as equipment manufacturers, government and defense contractors, and so on. So that's a little bit of an overview on us. Like I said, Rob and I are based in our Gaithersburg, Maryland, USA office. And Sanjeev is joining us from India. Okay, so let's dive right in and talk about today's topic. We want to first describe to you what is our MAPS APS solution. And then we will go over some test scenarios where you would want to use this type of solution. We'll describe the hardware platforms and what all the hardware consists of. We'll show you some basic configuration and operation. We have some screenshots that can walk you through how it all works. We'll go over different types of measurements you can do with this solution. And we will also describe NetSurveyorWeb, which is a nice, convenient web dashboard for viewing all of the results of this product. And finally, we'll also talk about API support, which is excellent for scripting and automation purposes. So that's today's agenda. Like I said, you can ask questions at any time, and we'll now dive in and explain exactly what this solution is and what it can give you. So first, some of you who are familiar with GL may know our MAPS product line. MAPS is an acronym. MAPS stands for Message Automation and Protocol Simulation. It's a very powerful software program that can simulate many different protocols. So as you see here on the right in this graphic, these are literally a lot of the different protocols that we can simulate with our MAPS platform. So whether you're on a TDM network, 2G, 3G, Ethernet IP, 4G, LTE, 5G, we can simulate a lot of different interfaces and a lot of different protocols on these networks. And the beauty of it is that it's one common framework. So, no matter what protocol you're trying to simulate, the software looks the same. It looks and feels the same. So, if you're doing one protocol today, and then a couple months later you need to simulate something else, you'll find that when you purchase a license for the new protocol, it'll look and feel just the same as the MAPS program that you've been using. So that's MAPS. It runs on Windows operating systems. And APS. APS stands for Analog Phone Simulator. This solution is very, very nice because it allows you to simulate analog phone calls. So this solution actually gives you up to 192 FXO ports. So basically, imagine 192 analog phone calls. So it's very nice solution. It scales very well, and you can do a lot of different types of calls and a lot of different capability there. So why do you want to simulate analog phone calls? So you may want to test your central office or a PBX or some adapters or gateways or whatever network infrastructure. You probably want to test it in a systematic way. And so this solution gives you the ability to test network infrastructure in a very systematic way by sending these predefined analog phone calls through it and measuring the performance of your device under test. Now basically we can do everything an analog phone can do. We can simulate all FXO capabilities. We list them here: on hook, off hook, call progress, tone detection, ring detection, digit and tone. We can send digits and tones and detect them. We can send voice files. We can record voice files, and so on and so forth. A whole list of different applications are here, including fax. We can also do fax transmission and reception with this MAPS APS solution. So you can define tone and ring cadences. You can have multiple concurrent users and tests per system. So a lot of times you have multiple testers, and they can all use the system concurrently. And each FXO port can be independently controlled. So again, it's not like all 192 calls are the same. No, each call can be completely independently controlled. So that's really the beauty of it. You can test a diverse range of scenarios all at once. And this last bullet here is very nice because we provide both the graphical user interface, and then we also provide application programming interfaces or APIs. So whether you want to do point and click and have a nice comfortable GUI, or whether you need to do scripting and automation, we can do both. And that's really what distinguishes us from our competitors, is our ability to do both. And there's just a lot of flexibility in terms of what we can do.
Can I jump in for a second,
yeah.
Vikram?
Yes.
Yeah, go back to the previous. Yeah, so a couple of things here. Number one, when we're mentioning we can support FXO, we can also support FXS. So we can either be the phone, the analog phone, or we can be the exchange or the station. So we can emulate either end of the call. It's a different piece of hardware within the MAPS APS solution, and Vikram will go into that a little bit later. But you can have both different types of cards, the FXO and the FXS, in the same hardware chassis, and then run tests the way you want to run it. Now, the other thing I wanted to mention is, so let's say you get a system with 192 ports, or you can scale down, you get 96 ports, 48 ports, whatever you want, depending on your requirements. We mentioned that each port can be independently controlled. And we also mentioned that you can have multiple users. Well, that's an important thing. So that all comes together, that you can set up one user to use a single port or a bank of ports, whereas another user is using a different bank of ports and so forth. So when we say multiple users, they can actually be running their own tests, their own set of tests, without disrupting this other user. So one MAPS APS can support many users running a variety of different types of tests. Okay, thanks.
Okay, thank you, Rob. So here on this slide, we just show a little diagram of how this works. We have our MAPS APS server, which is a rack PC with our specialized T1 quad card, which we'll talk about a little bit more. But basically, this card is a PCIe card that's in the rack PC, and it has 4 T1 or E1 ports, and you can connect one of these T1 ports to something called a channel bank. And so the via a crossover cable goes from our T1 port in our rack PC to a T1 port on the channel bank. And the channel bank will then break out that T1. As you may recall, T1 has 24 time slots. So you can have theoretically 24 different phone calls happening on each of those time slots. And the channel bank will break that out into these different analog FXO ports here. And then from the channel bank, it'll go out into your network infrastructure, out onto the public switch telephone network. So that's how the solution works. It's 2 pieces of hardware. We'll talk about it more in the next, in a few slides from now. But it's a very simple solution, and it gives you a lot of capability through just 2 pieces of hardware.
So each T1 is 24 channels. So each T1 will support 24 FXO ports. So if you plug all 4 of the T1s into the channel bank, then you're going to have 96 FXO ports. Okay, so that's why it's a quad. And if we wanted to do 192 ports, we would put an octal in the system. And then you would have 8 T1s, which 8 times 24, there's your 192. So that's how that works between the server and the APS rack there.
Yeah, and as Rob mentioned earlier, each of the analog ports serves as an independent analog telephone. So they can each be individually configured and activated for various, telephony tasks. Yeah, I guess we talked about all of these different bullets here. So this is how the solution looks schematically. Okay, so now we'll talk about different test scenarios. So like I said, we can simulate up to 192 analog phone calls. So the biggest, one of the most popular test scenarios is to do load testing. You can generate a lot of calls and send it into your PBX or whatever your network infrastructure is, and you can test whether it can handle all of those 192 calls, simultaneous calls. So by load testing it up with hundreds of concurrent calls, you can determine the true performance of your application. And again, you can keep it's long-term testing, so you can keep these calls up for more than 24 hours. You can keep them running indefinitely, really. So you can have all these calls running simultaneously and for indefinite time periods. So you can really do load testing in a really rigorous way here. You can also do feature testing, which we'll talk about a little bit later. But two-way calling, caller ID, call waiting, 3-way calling, vertical service code, all that type of stuff you can test to make sure your infrastructure can handle those features. One thing we're definitely going to talk about is voice quality testing. So like I mentioned, we can send and receive audio files, predefined audio files. And because you can send and receive audio files, you can measure the subsequent voice quality on those audio files. And we support the popular industry standard algorithms such as PESC and Polka to give you a true objective mean opinion score of the voice quality. So that's a really powerful capability that we offer. And again, for all of the different phone calls, you can get different voice quality scores. So we can do that. We can do voiceband measurements. And later on, we'll talk about interactive voice response, or IVR. So we can also traverse IVR trees and test out customers' IVRs. So these are a lot of the different types of test scenarios that you can do with this solution. Okay, so now let's talk about the hardware platforms in a little bit more depth. If you're familiar with GL, you know that we offer these PCIe cards, which are very nice. You can just stick them directly into the motherboard of the rack PC, and we have a lot of different form factors. We have a dual express PCI T1E1 card, so it has dual meaning 2 T1E1 ports, but then we can also scale up. So we have the quad card, which is what we showed in the diagram on the previous slides, and the quad card supports 4 T1s, and then we also have an octal card where we add another 4 T1s. So the octal card is this picture here, and it has 8 T1 ports. 8 T1s, like Rob said, multiplied by 24 time slots gives you the 192 analog phone calls. So these PCIe cards fit in our rack PC. We configure the whole rack PC for you. We install all the software, all the licenses. We install the PCIe cards. It's all up and running, ready to go when we ship this system. And so here you can see both the back panel and the front panel of this rack PC. It's just a simple 1U chassis, and here is the card in the back. Now the channel bank, again, there's different form factors for the channel bank. This is a 3U channel bank right here, and this is a 5U rack mountable channel bank. So depending on how many ports you need, you can tell us, and we can recommend the correct channel bank. So this is how, like I said, it's really just 2 pieces of hardware: the rack PC and the channel bank. So that's the hardware platform. So now we're going to talk about configuring the MAPS software and operating it. So like I said, we have a very comfortable graphical user interface where you basically can start a specific call and start multiple calls, and then you can see the actual ladder diagram for the call setup. So as the call is connecting, you can see all of the different signaling events that are taking place, and it's all easily viewable through our graphical user interface. Again, you can click on any specific call and start the call. You can place a call, you can answer a call. All of that is possible here. And again, you can have multiple calls running simultaneously. So yes, so we can generate 2-way calls with path verification. Basically we're running scripts in the background. So if you can see this, it says script name, and it says APS place call.gls or APS answer call.gls. These are just simple scripts that are running in the background that you can start in order to generate and receive the calls. And these are already configured for you, so you don't need to really go into them. So each physical port has a corresponding profile. We'll show you what the profile looks like on the next slide. But you can configure a lot of different things, like the calling number, called number, traffic action type, test parameters, and so on. And then the message sequence view is what you see here with these ladder diagrams, where you see each step of the test. So the graphical user interface is very easy to use. It looks the same for all of our MAPS programs. whether we're talking about analog phone simulators or whether we're talking about SIP calls or anything like that, it all looks and feels the same. Okay, so here are some more screenshots about our capability. Here we have multiple different calls, and they're all just shown in this top view here. We can just click on any call to start them, and then down here we kind of have aggregate statistics, so we can see like how many total calls have been placed, how many active calls there are, completed, past calls, failed calls, calls per second. This just gives you some aggregate statistics. And you can also graph the results in a really simple pie chart. So here we can see in a test that we ran, out of 189 calls, 5 of them failed and 184 of them passed. So there's a lot of different types of graphs that we offer. It's all in this GUI, and it gives you a really quick understanding of what's going on while you're doing your test. Now, there is way more information than what you just see here. So we do save all the call detail records and store them to a database. So the call detail records will give you much more details on the calls, and it'll store it to a database, and it'll give you additional information such as, you know, the reason for failure if a call had failed. So that's also, and we'll talk about call detail records later on when we discuss NetSurveyorWeb. Okay, so like I said, each call can be configured independently. So here you see on the left-hand side the profiles for all of the different calls. And for each call, you click on it, and then this is the profile that you see here. And so these are just some of the things that you can set. So you can set like the region, United States, right? So for like the area code and country code and so on. You can set the calling number, the called number, and, you know, the traffic type, and all these different things, you know, the digits and so forth. If you're doing fax, you could set fax parameters. If you're traversing an IVR, you can set IVR parameters. So it's all configurable, and it's all configurable through a nice, comfortable GUI for each call. You can save these configuration files, okay? So once you save the configuration, you don't need to go back in here every time you load the software and retype these parameters in. So, you know, if you've set up multiple calls, you save them, and then the next time you invoke the software, it'll automatically load them. Or you can load them just by, you know, loading the configurations from the drop-down menu. So that way you don't need to keep retyping in parameters. It's very easy to just fire up the software and run the test over and over again. Okay, so again, these are just more screenshots, what you can do. We've basically expanded this menu tree here so you can kind of see the different types of things you can do. Ring cadence, dial tone definition, ring back tone definition, busy tone, call waiting, distinctive call waiting, confirmation tone. These are all parameters that you can set. It's a lot of flexibility here. And again, we also have like text files. So you can, if you wanted to configure frequency definitions, you can do so through these multi-tone detector files. They're just text files where you can set these parameters as well. So it's very easy to configure everything. That's basically just what we're showing here through these screenshots. Global configuration. So once you set up, what I showed you on the previous slides were each individual call, but you can also configure global settings. So these settings will apply to all of the calls. So, you know, you can tell what type of digit you're dealing with. So is it dual tone, multi-frequency, or is it something else? The call duration, in milliseconds. So this call here is a 60-second call, or it's going to set all calls to be 60 seconds in duration. Path verification, voiceband measurements. So these are global parameters. So that way, these parameters apply to all of the calls. We have things like power level and so on. So that's all easy to do as well. Okay, so now we start to talk about some of the basic measurements you can do with the software. Recall that these are T1s, right? So each T1 has 24 time slots. So if you really wanted to see all the frequencies and the power levels for each of the time slots, we can also measure like the byte values and so on. You can bring all that information up. So you see here in these screenshots, TS0, that's time slot 0, time slot 1, 2, 3, all the way to time slot 23. So all 24 time slots are visible here, and you can see exactly what's going on. Card 1, meaning that's just one of the T1 ports. You can then scroll to the other T1 ports as well. For any T1 and for any time slot, you can get graphs of the power spectrum. And so here we're showing 2 different time slots, time slot 1 and time slot 0 of the same T1. So you can view all that information. And here again, we're just showing audio. This is in time domain, so we're just showing audio. So frequency domain, time domain, you can see all of that stuff here. It is very easy to view. Okay, so at this point, I'll turn it over to Rob, and he'll talk more in depth about the more interesting test measurements that you can conduct with MAPS APS.
Okay, thanks, Vikram. All right, so just to touch a little on what Vikram mentioned, there's a lot of things that you can do with the MAPS APS and configuring it and the scripting and setting things up and setting up the, for instance, the frequencies for the call progress tones and everything else. But GL can assist with all that. So GL can assist with setting up the scripts and setting up the configurations and so forth, because it could be, overwhelming. But we've done this for a lot, for quite a bit, and because we can set up different call progress tones and everything else, this solution works worldwide. So it's not limited to one area or only certain frequencies. Everything is user configurable and very easy to set up. So with that said, going over to some of these test solutions within the APS. So first thing here is voiceband measurements. So what we could do here is basically with the audio going across the APS from one end to the other, or from the FXO to the FXS, or from one FXO all the way over to the other FXO, we can measure different voiceband characteristics of that audio, such as the noise ratio, or the noise levels, the signal levels, 3-tone slope. All these things can be measured. So you can configure the APS to measure these, then you can get these measurements out and review how your testing solution is working. Okay, go to the next slide. Vikram? Thank you. Okay, voice quality testing. So as Vikram mentioned earlier, again, we can send and record audio. So if you're going to send and record audio over the network, over the 2-wire network, we can then take the recorded audio and analyze that using the either the Polka, which is the latest algorithm, or the PESC, which is the earlier algorithm. So PESC is based on ITU P862, and Polka is based on ITU 863. They both use the same methodology of taking a recorded or degraded audio file and analyzing it against the reference or file that was sent. The file samples are very small, around 5 seconds. We can include male or female or a combination of male and female, and we have a variety of languages also that we support. If you want to use your own files, that's possible too. So what happens is after you run the voice quality test, you'll get a VQT score, which is based on 1 to 5. And then you'll also get some additional analytical measurements such as speech level gain, noise level gain. You also get jitter. So this will all give you an understanding of possibly why the score was what it was. We also have other measurement tools that we can use to give you a more clear understanding of why your score was what it was. So, for instance, in this case, the score is 4.02, which is pretty good. But if the score was 2.5 on a scale of 1 to 5, then you may want to know, well, why was it 2.5? And you may get that information out of the speech or noise level. But we have other tools that can also give you an idea of, well, were there any audio dropouts? Meaning, was there loss in audio during the 5-second transmission? Was there a change in the frequency or the power? So there's a lot of other things that we can do, and so we have other tools available for that as well. Okay, next slide. Okay, so IVR testing. With an IVR or even a voicemail type of scenario, we can go through the entire process of testing. So, for instance, an IVR, you're going to call into the IVR. It'll give you a prompt, and maybe you have to enter a digit, or maybe you have to enter a credit card number or a foreign phone number. So all this back and forth can be done using the APS. So using a specific script of detecting where we are in the IVR based on detecting energy and silence and so forth, and then sending the proper DTMF digits throughout the IVR. Now, so that's one thing. So we can traverse the IVR. But the other thing is we can confirm that the prompts coming back to us are proper. So we have something called speech to text. So we can capture the audio coming back to us, the prompt, and then convert that to text, and then confirm if that text is indeed what we expected. So confirm that the prompt is proper. We can do the same thing with testing voicemail. Basically traverse the IVR and then send or deposit a voicemail into the system by sending audio into the system and then retrieving that voicemail and confirming it is what we sent. So all this can be done with the MAPS APS, all automatically using this script. And just to note, all the different things that we're talking about, the IVR, the VQT, all the other audio metrics, they can all be done within the same call. Or you could set up a script to do one thing one time, another thing another time. So everything is open-ended to what you want to do during your testing. Next slide. Okay, so feature testing, we mentioned this briefly in the very beginning. So using the APS, we can do any type of feature testing you want based on what the network supports. So what does that mean? Well, first of all, we can detect the FSK, meaning the caller ID. So we can detect and decode the caller ID that is coming during the incoming call between rings 1 and 2. So we'll detect the FSK, decode it, and then we can determine what that caller ID is. We can also detect the FSK during a call, so it's call waiting with caller ID, so we can determine if there was call waiting, and then also show what the caller ID was in that respect. Now, the other thing we could do is during a call, we can set up these different tests like two-way calling, three-way calling, call forwarding, things like that. And normally the network will request a flash hook and then sending DTMF. So we can do all that. So we can set up a flash hook. We can actually determine how long the flash hook is going to be. We can send multiple flash hooks for that matter. And then send DTMF. So by doing that, you can configure a different service during that call. And then we can confirm that that service is set up. So you have the ability to do a flash hook, to send DTMF, detect tones, detect the FSK either prior to the call or during the call, and also send and record audio. So there's a lot of different things you could do with the APS in order to fully test the network. Okay, thanks, Vikram.
Okay, thank you, Rob. Whoops, sorry. Okay, yeah. So now we'll discuss NetSurveyorWeb, which is a really nice, convenient web dashboard to basically view all of the calls that are taking place. So a lot of customers have asked us, do you have any, web-based graphical user interface? And yes, we do. It's this NetSurveyorWeb. So here you see the screenshot for it. NetSurveyorWeb, well, there's two components to it. There's a backend database, which is holding all of the call detail records. And then there's the web front end dashboard, which conveniently displays all of the calls here that are taking place. So a couple things to notice in this screenshot here. So first off, you can click on any given call and you can see a lot of information on the call. Is it pass or fail? What was the duration? What was the calling number, called number, and so on and so forth. You can actually expand these calls as well. So it'll display all of the calls here. You can click on any one of them and get more information on them. You can plot. You can look at the the last day's worth of calls, or the last week, or the last month. It's all configurable because it's just reading that database. On the left-hand side, you see a lot of other possibilities here. You can just, right now we're viewing all of the calls, but you can also view failed calls, voice quality testing calls, meaning on that call we conducted a voice quality test, and so you can get the results of that voice quality test and display those. You can look at the fax calls and so on and so forth. For voiceband measurements, you can view all the voiceband measurements here as well. You can customize the call detail record. So you can click here and you can actually generate custom call detail records where you only see certain columns that you're interested in. So this is what the NetSurveyorWeb system looks like. And because it's a web-based system, you can actually log into it from anywhere. So this could be running on some central system. It could be running on the same rack PC that we showed you before, or it could be running somewhere else. And you can remotely log into it just by opening a web browser and typing that IP address, and it'll pull up the NetSurveyorWeb. So this can be deployed on the same system or on a central system. You can imagine if you have multiple test equipment deployed throughout your network in different geographic locations, all of them can be sending their data back to this central system, back to this central database and this central NetSurveyorWeb system. So you see here probe name, and so this is all coming from the same system, the same channel, same one complete MAPS APS system. But you can also have multiple MAPS APS systems around the world, and they could all be sending data back to this dashboard. So you can actually filter on whichever probe name you want to look at. So it's a very scalable solution. So these are just more points. I think I actually mentioned some of these. But yeah, you can export the call detail records as a PDF file or a CSV file. So, if you want to do your own analysis on the call detail records, export it as a CSV, and then you can use whatever program you want to analyze that CSV, whether it's Microsoft Excel or whether you're writing your own, post-processing scripts or whatever. You can set custom filters. You can filter on a specific date or time or other call control parameters. Like I said, you can filter on a probe, a specific probe, a specific calling number, and things like that. You can apply single or multiple filters. So you can say filter on this condition or that condition, or filter on this condition and that condition. So you can use logic operators to really define your filters whatever way you want. Now, one of the really powerful features is our ability to generate alarms and alerts. So let's say you've set some alarm where, every time there's a failed call, generate an alarm. And it'll do that. It'll show up on the dashboard as an alert. And it can also send email notifications and so forth. So you can generate alarms on all sorts of different conditions. Whenever a specific number is dialed, you can generate an alert on that. You can generate an alert based on voice quality score. So maybe you're, all the calls have good voice quality, and all of a sudden you get a call that comes in with like a score of like 2.3 or something. And so that has a poor voice quality score, and so then you can generate an alert when all of a sudden you have a poor voice quality score. So the alerts are very nice, especially when you have lots and hundreds of calls or thousands of calls taking place. You can't just look through every single call manually. You need some sort of alert-based system. So that's what we can do with that. Okay, so that was NetSurveyorWeb. Just one other thing about NetSurveyorWeb. It works with all of our different MAPS products. So it's not just our analog phone simulator, but you can also have our other MAPS products sending data to NetSurveyorWeb. So you can view analog calls, you can view voice over IP calls, you can view a lot of different types of calls in this dashboard. Okay, so now we want to definitely emphasize our API support. So API stands for Application Programming Interfaces, and more these days we have customers asking for scripting capability. Graphical user interfaces have their limitations. If you want to run a test every hour on the hour for a specific duration and under specific conditions, you sometimes don't want to have to invoke the graphical user interface every hour and then click start and then do it again the next hour and so forth. So that's where scripting comes into play. That's one example of how you can just write a simple script to automate the testing and do repetitive testing and so forth. So we have APIs available in multiple languages. The most popular ones are Python and Java. So if your engineers like to do scripting in those languages, they can just simply invoke our APIs in their scripts, and they'll be able to fully control the MAPS APS system. Furthermore, they don't have to be at the physical location of our MAPS APS solution. They can be located remotely. They could be anywhere in the world. As long as this MAPS APS system has an IP connection, they can, from whatever office or their home, they can remote in to the system, and they can run the scripts on their own PCs, the Python and Java scripts on their own PCs, and it'll send commands to the MAPS APS, which will execute those commands and send back the results. So remote capability here is really a powerful feature that we offer that a lot of our competitors definitely do not offer. So that's what we can do. And again, you see multiple different workstations, so multiple users can also connect to the MAPS APS system and run commands. So it's not like just one user at a time. So that's what this bullet is. Allows unlimited number of users to operate MAPS APS simultaneously. You can reserve or release an analog port through the API. Okay, so if you need to use a specific analog port, then you can reserve it for yourself. And basically everything that you can do through the graphical user interface, you can also do through APIs, everything. You can start a call, stop a call, get all the test results, failed calls, successful calls, all of the results, everything you can do through the APIs as well. Full flexibility, any test scenario, call flow, all of the feature testing that Rob mentioned before, you can do it through these APIs and through these scripts. So yeah, this shows you the versatility and the power of this solution. Oh, and by the way, again, we have application programming interfaces for not just MAPS APS, but for all of our MAPS products. And for that matter, we have it for a lot of our other products as well. So APIs is something that we offer for many of our different telecommunications test and measurement equipment. So no matter what product you're interested in, we probably have APIs that can support your scripting and automation needs. Okay, so yeah, again, these are just all the different types of functions you can do through the API or through the GUI. On hook, off hook, hook flashes, dialing, sending digits, receiving digits, file transfer functions, sending a file, receiving a file, recording files, FSK related functions, tone related functions, audio path confirmation, so this is the voice quality stuff again, and fax as well. So fax, you can send fax, receive fax. That's all possible with our solution as well. So kind of without, I think we talked about a lot of this stuff already, but this slide just sort of summarizes a lot of the different types of things you can configure and things you can do.
Yeah, with fax, so we do. I didn't mention that, but with fax, we do support up to V34. You can set up V34, V17, V27, whatever you want to do. But we do support up to V34, 33.6 speed, and this is for sending and recording. And we basically just use TIFF files for sending and recording, and they can be single or multiple pages. And that can be configured within the script during a call. You can set this up.
Yes. Okay. So Here again, I won't walk you through all of the code. This is just to show you some snippets, like you can write Java code, you can write Python code. So these are just some kind of snippets. It's very simple. There's just a few things I do want to mention. You know, like for instance, this very top line here, this is where you type the IP address of the MAPS APS system. So again, like I said, you can connect remotely. As long as the MAPS APS has an IP connection, you can connect from anywhere. You give it the IP address, the port, and then you can connect to that MAPS APS, and you can pass commands. So you can tell it to go off hook, dial a tone, you know, detect the ringing signal, detect the ringback, you know, all that stuff. So line 1, line 2, and so forth. So it's very easy to just, in a simple script, control each analog phone call. And again, you know, whether it's Python or Java, the APIs look the same basically, you know. So you can do everything you need to do. Yeah, this is what we're showing here is just like a simple call flow. So, you know, line A goes off hook, it dials, it detects the dial tone, it dials line B. Line B detects the ringing, detects the caller ID, and then line A hears that ring back tone, and then line B goes off hook and answers the call. So line A is now talking to line B. It can send tones, detect tones, and vice versa. And then here we show you like a third call that gets introduced while line A and line B are talking. So now we have line C going off hook and dialing line B. So you know, you can have call waiting, and you can have three-way calling, and so on and so forth. And this is basically what this is showing here. This is like a simple scenario where you're doing where you have multiple calls set up. So
in that scenario, so let's say you had a three-way call, for instance. So now, well, how do we confirm the three-way call? How do we confirm the audio? So we could send DTMF from one of the lines, and the other two lines can detect it and confirm that the DTMF was received. Another thing we could do is send audio from one and then do a voice quality in the other two. So there's different things that you can do to not only set up the three-way or two-way or conference calling, if you want to set up a conference call, but now you can also confirm that the audio path is proper on all the calls within the conference or the three-way or what have you, and what the quality is. So all that's available.
yes. And the very last slide for today's presentation, as Rob mentioned earlier, we can also do FXS, so we can simulate being a central office or a PBX. So you know, we have FXS ports on that channel bank. So again, up to 192 FXS ports. And we can do the basic functions. We can assign a telephone number to each line that's connected to the to that port. We can route the calls between two endpoints. We can function as like a full-blown central office switch simulator. From ingress SS7 to egress, you know, plain old telephone system. So so we can also act. So we also have FXS capability, and we have a little screenshot here where we again show the ladder diagram. Again, it's the same MAPS framework. Now we're just running a script to do FXS setting up. So we can do that, and we can also do E&M simulation, 4-wire E&M, And again, we can do all sorts, the same types of traffic actions we did before. We can send tones and digits, voice files, fax. We can do voiceband measurements and voice quality. So whether it's 2-wire or whether it's a 4-wire E&M, we can do we can support both. So depending on your requirements, we can definitely support those, a lot of different scenarios.
This is just different cards that go into the channel bank, whether it's an FXO card, an FXS card, a 4-wire E&M card, or a combination of the different cards. It's whatever is in the channel bank, and then your physical connection of the T1 to the channel bank will control that card. So one T1, for instance, can control FXO, while another T1 can control the FXS. So that it's all that could all be set up.
Okay, so thank you everyone